Pre-calculus 4.6 day 1, we are looking at graphing tangent and cotangent. And one of the main difference between sine and cosine and tangent and cotangent is the period. The period of tangent is pi, the period of cotangent is pi. And then we have what we call vertical asymptotes for tangent and cotangent, because we have places where tangent and cotangent are undefined. And those are x equals plus or minus pi halves. Those are the equations for where a tangent is undefined, versus on cotangent, we have asymptotes at x equals 0 and x equals pi. And then since being their period is pi, if we add pi to each of these asymptote values, or multiples of pi to each of these asymptote values, we are going to get another asymptote, because the period length is pi, and every pi units you have another asymptote. And one way we describe that is I can add any multiple of pi. So I can add 1 pi, 2 pi, 3 pi, or negative 1 pi, negative 2 pi, negative 3 pi. So we do this with a variable. We say n, where n is an integer. And that gives me the equations of all my asymptotes. So you take whatever the period is times n and add that to one of the asymptotes. And with cotangent, because one of them is at 0, the next one's at pi, the next one would be at 2 pi, the next one would be at 3 pi, or if I go to the other direction, x equals negative pi, x equals negative 2 pi, x equals negative 3 pi. They're multiples of pi. And so what we can do is, again, write it as pi times n. And if n was 0, that would give me x equals 0, this first one. If n is 1, that would get me the second one. N is equal to pi. If n is negative 1, I would get x equals negative pi as one of those asymptotes. And so these asymptotes are pi units apart, but they're in different spots for tangent and cotangent. I want to take a moment and just review why that happens, attaching it to the unit circle. Oops, okay, come on. There we go. And so at 0, this ordered pair is 1, 0 on the unit circle. And so if I make a chart with theta, and I think about tangent of theta, and I let theta be 0, well, tangent's defined to be y over x. And so you get 0 over 1, which is 0. So tangent is going to be 0 at 0, so 0, 0 is a point. The origin is the point 0, 0, and that tangent goes through it. And so for cotangent of theta, it is x over y. And so I get 1 over 0 when theta is 0, but that's undefined. So that's why over here, x equals 0 is a vertical asymptote. The places where you have vertical asymptotes are the places where tangent and cotangent are undefined. If I move up to pi halves or 90 degrees, I'm at 0, 1. And so if I'm at that pi halves, tangent is y over x again, and 1 over 0, I can't divide by 0, so tangent's undefined. And that's why one of the asymptotes is x equals pi halves for tangent. Now for cotangent, it's x over y, so you get 0 over 1, and that is 0. So cotangent is 0 at pi halves. If we keep going at pi, we have a negative 1, 0. And so tangent is going to be 0 over negative 1, which is 0. But cotangent being x over y, is going to be negative 1 over 0. You can't divide by 0. It's undefined. And if you keep on going and think about 3 pi halves, you're going to get tangent to be undefined. Notice that's pi units away from pi halves. So if I add pi to pi halves, I have 3 pi halves. There's a place where we have a vertical asymptote. And cotangent is going to be 0 again. And if we go to 2 pi, which means we've gone 2 periods, because remember, tangent's period and cotangent's period is pi. So 0 to pi, you get the entire footprint of tangent. If you get to 2 pi, you've gone through 2 periods of tangent, and you're back to 0, and cotangent will be undefined. Now, the basic footprint of these, tangent increases. So tangent increases, and it looks something like this over and over and over again. And what you get between each of the footprints is a vertical asymptote. So between two asymptotes, you've got 1 period of pi. And so tangent kind of looks like x cubed. It's increasing, and it has a change in concavity at 0, 0. For cotangent, it looks like this over and over again. And you have vertical asymptotes between each of those footprints. So cotangent looks like a flipped x cubed graph. And they aren't the same because when they follow the vertical as x cubed or a flipped x cubed, because as they follow the vertical asymptote, they never cross over it. They just keep getting closer and closer and go to positive or negative infinity. Anyway, so let's look at some of these graphs. The standard form looks a lot like sine and cosine, but you have to remember that the period is pi. And one of the big things about that then is when you have a b other than 1, to find the new period, it's not 2 pi divided by b, it's pi divided by b. And we'll see that as we look at a period change. The A is not amplitude, it is a vertical stretch or shrink. It's a vertical stretch or shrink. And if A is negative, there is a reflection in the x-axis. So let's look at this first graph, tangent. And the period of tangent is pi. And so we still are going to have key increments, 1/4 of the period. So the key increment's going to be pi fourths. And we expect vertical asymptotes. You need equations, x equals negative pi halves, x equals pi halves. And we're actually going to go ahead and draw that in. And I'm going to mark this by the key increment. I'm going to go left pi fourths, right pi fourths, left, make that a little bit bigger. Left negative pi halves, right pi halves. And on negative pi halves and pi halves, we have vertical asymptotes. The function's going to approach them and get closer and closer, but not actually touch them. And we just saw that at 0, tangent is 0 on the chart. And at pi fourths, tangent is 1. Tangent is 1. If you remember again, on that unit circle, that at pi fourths, that is the point root 2 over 2, root 2 over 2. So the tangent of pi fourths is going to be 1. And then if I rotate and go clockwise pi fourths, this point is root 2 over 2, negative root 2 over 2, when the reference angles are 45 degrees or pi fourths. And so the tangent of a negative pi fourths is a negative 1. So it goes right here. And they look like they're kind of linear in a line, but you don't want your graph to look linear there because this graph is going to be, concave down. So we want it to show that it's concave down. And it's going to get closer and closer to that asymptote as it goes down, but never cross it or touch it. And then to the right, the graph of tangent's concave up. So you want to show that, and then it's going to get closer and closer to that asymptote. And there you have one footprint of tangent. That is 1 period, because that distance between those is pi. And then we just keep on going, 3 pi fourths, pi, 5 pi fourths, 3 pi halves. That next asymptote, add pi, x is equal to 3 pi halves. And in the middle, we have 0. To the right, a key increment will be at 1. To the left of the 0 will be at negative 1. And then we draw something similar to that. Make sure you have that change in concavity. And there we've got a second period. Now for cotangent, I told you that it's gonna look flipped. And also the vertical asymptote is x equals 0 and x equals pi. So the y-axis is a vertical asymptote. And we're going to go by key increments. Pi fourths, pi halves, 3 pi fourths, and then at pi we have a vertical asymptote. And so we have the period for cotangent is still pi, and the key increment is still 1/4 of the period, or every pi fourths. And we have vertical asymptotes at 0 and at pi. Now, in the halfway, right in the middle of the two asymptotes, just like tangent, we're at 0. But in quadrant 1, tangent and cotangent of 45 degrees are both either 1 or negative. In quadrant 1, it's going to be +1. Remember, it's positive. All the trig functions are positive in quadrant 1. Pi fourths is a quadrant 1 angle, so it's up at 1 here. But when you get to 3 pi fourths, again, this point would be -√2/2, +√2/2. So the cotangent of that, x over y, is -1. And that's where we get that cotangent has that decreasing change in concavity at the 0. And there is one footprint of cotangent. And then we're going to continue to mark by pi fourths until we get to 2 pi. Right? If I have x is equal to pi, if I add pi, I'm at 2 pi. There is another vertical asymptote. Halfway in between there is 0. To the left, a key increment, we're at +1. To the right of the 0, we're at -1. And then we can draw a second period. Oops. Trying to get that in there. I don't know if I can get this to erase or not. Yeah, too much. Oh well. Again, because I want to see that change in concavity. All right, so there is your tangent and cotangent. And so then we're going to move on, and we are going to be doing a vertical stretch, which is going to move these points. If we do a vertical stretch, the places where it's 1 and -1 will be stretched. The zeros won't be affected, but those points at the key increments will be affected. So example 2. The b value in here, it's a 1x, so b is just 1. And the a value is 2, which means we're going to be stretching these at 2. So what we're going to, and our phase shift is going to be right pi halves. So my period is still pi. My key increment is pi fourths. And my asymptotes are going to shift. So I don't want to get those equations yet. I have my phase shift is right pi halves. So let's look at this before phase shift. So if this was y is equal to 2 tangent of x, I would take my period, remember it would be at 0, 0, and then my key increments is pi 4, so this is a negative pi halves. This is a positive pi halves. And so these would be my asymptotes before, this is the y equals tangent, 2x. And the 2 is just going to make it 45 degrees that it goes up to 2, and to the left 45 degrees it goes down to -2. So it has this vertical stretch to it. So there's one graph of it. But now I need to move it to the right pi halves. And so I'm going to go ahead and let's see. We'll do it in green. So if I'm getting to y is equal to 2 tangent of x minus pi halves, I'm going to take all these key points and move them pi halves right. And pi halves is equal to 2 pi over 4, right? Get multiply by 2 over 2. And so I have to move 2 key increments to the right. So the asymptote is actually going to move and be on the y-axis, and the pi halves is going to move 2 key increments to the right and be at pi. So my vertical asymptotes, x equals 0, x equals pi. The next one's going to be at x equals 2 pi if I go for 2 periods, because there wasn't a period change in the period, still pi. And right in the middle of those two asymptotes is 0, 0. And so then to the right, I'm going to be up at 2. If I go to the right, a key increment. To the left, I go a key increment. I'm going to be at negative 2. And there is 1 period of this tangent graph. But we're going to want you to go for 2 periods. So I'm going to just count 1, 2, 3, another set of key increments. And that's that x equals 2 pi. Halfway in the middle is 0. There's the stretch of 2, every key increment, and oops, don't quite like how that went away from the asymptote. I want to get closer and closer without touching it. And so there is the second one. All right, cotangent with a period change and a reflection in the x-axis, which means normally cotangent goes like this, but that's not going to be the case because when it reflects, it's going to go like this, and therefore it's going to look a little more like tangent, but it is a cotangent graph. All right, so on this one, oops, with this negative 1/2, that means I'm expecting, if there was no phase shift, okay, if there was no phase, or let's back that up. Just where this function would normally be at 1, it's going to be at negative 1/2. Where this function would be normally at negative 1/2, it'll be at positive, or at negative 1, it'll be at positive 1/2. So it flips and it's a vertical shrink. That's what's happening there. And so let's look now, period. This is important. It is pi divided by b. And so b is 2, so my period is pi halves. And my key increment is going to be 1/4 of this period. So it's going to be pi eighths. And so I'm going to grid out the graph by pi eighths. So I have a pi eighths. I really don't care if you reduce it or not. 2 pi eighths, 3 pi eighths, and then 4 pi eighths. It's just going to be easier for me to write 1/2 here. And that's going to be, that would be 1 period. And there is no phase shift on this one. So there's no C. So remember how the graph of the asymptotes, since there is no phase shift, the asymptote is going to be at x equals 0, and the next one's going to be 1 period away, x equals pi halves. The next one's going to be 2 periods away, pi halves plus pi halves is pi. So if I go for 2 periods at pi, I will have another asymptote. You've got to make sure that you label your scales on here, on the x-axis. And if you change the y-axis and don't let one box be 1 unit, you need to make that clear as well. And so for this, halfway in between the asymptotes is always a 0. And then 1 key increment to the right or left would be normally 1 and negative 1. However, this has been reflected. And so I'm going to go ahead and let this be negative 1/2 and this be positive 1/2. So this is 1. This would be 2. Make it very clear, you know, what's going on there. And so, but it's reflected normally, remember, normally it decreases. Quadrant 1 it would be positive, but when you take a positive 1 times a negative 1/2, you're at negative 1/2. And in what would have been quadrant 2, you would be at negative 1, but take that times a negative 1/2, and you're at positive 1/2. And so without showing the scales, I would never know what you graphed. And you can't get credit because it looks the same. So there you go. There's 2 periods. And you'll be needing to give the equations of those vertical asymptotes as well. All right, so let's look at one that kind of has a little more to it, has period change and a phase shift. And so we have, to put this in the correct form, this is cotangent. I need to pull out the 3. And when I pull out that 3, when I pull out that 3, I am dividing each of the terms inside there by 3. And this simplifies to x. People do fine with that, but the pi halves divided by 3 is pi halves times 1/3. You divide by 3, multiply by the reciprocal, and you get a pi 6. So this is going to move to the left, pi 6. It's going to move to the left, pi 6. There's also going to be a vertical stretch of 2, and there's a period change. So the period is pi divided by b, and my key increment is 1/4 of that, and so it's pi 12ths. And then my phase shift is left pi 6. And just like what I did with sine and cosine, we want to look at the key increment and the phase shift and write them with a common denominator. So the phase shift is going to be 2 key increments to the left. And so I'm going to grid this out by pi 12ths. And 4 pi 12ths is that pi thirds. And so the normal graph of cotangent would be a vertical asymptote at 0 and a vertical asymptote 1 period away. And then halfway in between would be your 0, 0. And to the left a key increment, remember there's a stretch here, so we would be at positive 2 because there's no reflection. And to the right a key increment, we'd be at negative 2. And this would be, before my phase shift. That would be before my phase shift. But now the phase shift is 2 of these key increments to the left. So the y equals 2 cotangent 3x plus pi 6. I'm going to move 2 key increments to the left, which is a negative 2 pi 12ths. That's going to be an asymptote. And I'm going to take the pi thirds and move it 2 key increments to the left. That asymptote. So both asymptotes have to move 2 key increments to the left because that's the phase shift. So those are equations are x is equal to a negative pi 6. Negative 2 pi 12ths is negative pi 6. And positive 2 pi 6 is, or 2 pi 12ths is positive pi 6. So my vertical asymptotes, x equals negative pi 6, x equals pi 6. And those are the 2 that contain 1 period. Move these points 2 key increments to the left. And there is, oops. There's my 1 period. And if you add the distances, it's 2 pi 6, which is 2 pi 6, which is pi thirds, which is your period. And then I would just repeat this. I've got it marked by key increments. So another one is pi 6 plus the period, which is pi thirds, or 2 pi 6. So it is 3 pi 6, or pi halves. So the next one is x equals pi halves. And so repeat, in the center is 0, 0. And there is my other cotangent. So that's 2 periods of cotangent. There you have it.